So as I left you in the last video, I mentioned that we're going to use an Arduino to pull off the data taking in this experiment here. So of course, once again, remember sort of the average number of counts we're getting, somewhere in the mid 600s, let's say about 650 counts per second on average is what we're getting. Sometimes it's higher, sometimes it's lower, but it's a number sort of like that. You're going to want to remember that. And what I'm going to do now to get this going is I'm going to go ahead and pull this cable off and just get the scaler out of the experiment. We're not going to use it at the moment here. And what I'm going to do instead of the scaler is I'm going to take another cable here, this one right here, and I'm going to plug it in. And this cable here is the one that goes to the Arduino. So on the end of this cable here, sort of a clever design, there's a black and red alligator clip. And I'm going to have the black clip plugged into the ground on the Arduino and the red clip plugged into pin 3 of the Arduino. So if you may or may not know about the Arduino, but these pins here talk directly this 5-volt language here. So these pulses here that come in from the SCA can be directly interfaced to the Arduino, and the Arduino will indeed recognize them. So now I know I'm feeding the pulses into the Arduino, so all I have to do now is write some software to look for a pulse coming in on pin 1, start a timer, keep that timer running until another pulse comes in on pin 3 there, stop the timer, display the time, and keep going. Repeat the cycle. So the way we're going to go about it is the one thing that's nice about these square pulses here is they have some very well-defined features. The most important one for this is the so-called rising edge of this pulse. See, there's no pulse, no pulse, no pulse, but suddenly the pulse has to rise and then stay up to indicate the presence of the gamma ray, and then fall again and go out. So this is called the rising edge, and this is called the falling edge. So it turns out the Arduino at the hardware level can be programmed to recognize the rising edge of a pulse, the rising edge. And that's going to be our clue. This green line stays pretty silent at 0 here until the edge rises, indicating the presence of a gamma ray. And so that's what we're sort of going to hone in on as we write some software to do the timing for you here. So the software is online, you can find it, but I thought I would just talk you through it a little bit here just so you get a basic understanding of what we're going to do here. Okay, so the first thing you see in the software here is we have a couple of conditions that the software is going to be in, namely start and end. And those are just sort of some logic that I'm going after to get us going here. Start means it's waiting for that rising edge, and ends means it's found a rising edge and is waiting for another rising edge to stop the timing sequence. And of course pin 3 is the exact hardware pin that this red line is connected to on the Arduino. It has 13 pins, and so we're just using pin 3 at the moment. Okay, and so here's what we're going to do. Get some focus first. As the Arduino starts, we're going to set an interrupt on that pin. Now what an interrupt is, the only thing I want to tell you is the Arduino runs at about 16 megahertz. The little clock in there runs about 16 million times per second. And see this word rising right here. The word rising right there tells the Arduino that we want it to wait for a rising edge of a pulse. Where's that rising edge going to come from? Well, in the case that a gamma ray arrives, we're going to wait for this rising edge right here. And when that happens, what interrupts do on the Arduino in sort of a very precise way is it immediately pauses whatever the Arduino is doing and calls this function called edge here. And that's just a name that I gave, like the edge is here. Okay, so that's all that does. So the Arduino is always going to be looking for rising edges on pin 3. And then let me just show you what happens here when it gets to edge here. The function that's called when it sees a rising edge. If it's in this waiting to start here, then basically it reads the number of microseconds on the system clock, and just that's sort of like our T0, start with some microseconds. If it sees the end status come in, it's going to read the number of micros again and subtract it from that original time it started with. So that's going to be our difference between pulses right there, the difference between rising edges, pulse A to pulse B to pulse C. Those are going to log those differences. Then there's some other logic in here just sort of to store those counts here, but the bottom line is if I run the code then, it's going to compile it and send it out to the Arduino. And just a minute here, let me make sure we have everything all set up here. I have to choose the right port. Board to run, there we go. Let me just try that again. Then what's going to happen still didn't go in for some reason.